Let's use a second example. Second problem. This is picking the right well pump. If you have a well in the ground, and generally speaking, wells are sized by horsepower and or capacity in terms of gallons per minute, but generally speaking, they're sized by horsepower. So when you're picking the right well pump, you want to make sure that for the depth of your well, that is how far up your pump needs to pump, you get the water pressure you want in your house. If you oversize it, then your pump will be cycling. It'll be pumping really fast, really hard, and then stopping. And then pumping really fast, really hard, and stopping, right? And you'll be wasting energy, and you'll have to, probably require more energy than you need, and it won't be an ideal scenario. So ideally, you want to size your pump to just the right amount to pump up to the right pressure given the height of your well. So you really want to minimize the size of the pump. Also, more expensive pumps cost more money. So you don't want to spend too much money on a pump. So the question is, what model of pump could I buy if my well depth is 300 feet and I want to pump water at a rate of 10 gallons per minute? So let's look for this data. Now this is a manufacturing table from a particular brand of well pump. So I want to pick among this brand of well pump model numbers. So let's go look at the table for step one. Step one, let's make sure the table has got the right information in front of it. Let's bring that little thing to front. So at the top of the table, I'm reading submersible well pump performance at 40 psi discharge pressure. And right below that, it tells me depth to water in feet, capacity in gallons per minute. Does that match the data that I'm looking for? Yes, it does. Number two, is this going to provide me in the rows and columns the information that I need? And if I look at the top here, I can see that I've got at the top depth of water in feet. It starts at 20 feet and goes to 500 feet. Is 300 foot in that list? Yes, it is. Do I see gallons per minute as one of the columns here on the left? Actually, let me bring this to front. Yes, I see I see various gallons per minute in the ranges of what I'm looking for. So yes, it matches. So let's get into the actual solving of the problem. In the solving of the problem, I need to pick the well depth. In this case, it's 300 feet, which is this row right here. Let's move my number one over there. Okay. And then I just go down that column, and I only have 1, 2, 3, 4, 5 choices in that column. And those are my capacities. So which of these models can handle at least 10 gallons per minute? Well, I don't just have one answer. Now I have 3 answers. So number 4, I pick the right answer in my, let's bring this to front. I pick the right 3 answers. 1, 2, oops, I didn't mean to do that. Just drag it down. 2, 3. So I have 3 possible answers. So I've got 3 model numbers I can choose from that are at least 10 gallons per minute. And here I can use the R214A, I can use the R314A, or I can use the R31015A. I have 3 possible answers that I can use based on my depth of well. Notice all 3 of these are a 1.5 horsepower motor. So they're all very big well pumps. So how would I choose among those 3 models? Well, that might be based on some other factor, like we might find out that one model is more suited to the kind of well that I'm digging. It might be a better style diameter, better diameter. Maybe it's better suited to the kind of water that's in the reservoir that I'm pumping out of. So I would need to choose among those three models to pick either the most cost effective or the best match for my conditions. We go. Okay, so now we're going to talk about sample problem 3. This one is something you already should have familiarity with. And in sample problem 3, you as an electrician need to size how big a wire you need to buy. How big a wire you need to buy using the NEC standard table to make sure you sized your wire properly. Here's the risk. If you buy too small a wire, right, then it will overheat and potentially catch fire to your building. You don't want to do that. If you buy too big a wire, well, it's not so big a risk, but you will be spending extra money because copper wire is expensive. And in this particular example, step 1, which is choosing the right table, is critical. Because if you look up, here I am showing my booklet here, if you look up these tables in your Uglies reference or your generic reference books, you're going to see a dozen different tables about wire sizing. So you have to make sure you're choosing the right table, right? And so let's begin this process here. Just bringing these all to the front before I start. All right, so the problem is what size, in this case, we're using AWG as the American wire gauge, the standard size. Copper, THHN wire do I need to buy if I'm running a single conductor in 75-degree air, which is your generic standard for a reasonably temperature-controlled environment, like an indoor environment, with 100 amps of power. 100 amps is a lot of power. A normal whole house is set up with 200 amp service, so 100 amps is half of what a house would normally take. So the first thing I'm going to do is look up here at the top of the table. Number 1, all right, it's NEC, allowable ampacity. Ampacity is the allowed number of amps for insulated rated conductors for the 0 to 2000 volts. Well, I didn't give you the voltage, but the implication is it's probably in a pretty standard range, which is in the 0 to 600 range. So unless I specified 1000 volts, you're going to assume it's going to fit in this table. Then down below it says ampacities not more than 3 current carrying conductors in raceway cable or earth. Whoa, 3 current carrying conductors. Do I have the right table? No, I don't, right? Because I ask about a single conductor in 75-degree air. So this is the wrong table. I need to choose a different table if I have a single conductor in open air. That's a different table. A single conductor in open air can handle more current than 3 conductors held together in a conduit. And the reason for that is the conduit and or the wire sheath keeps that heat in around those conductors. Therefore, you can't really put as much current through it as you would with a single conductor in open air. So let's go down to the second step in the problem because we can't do the first step with this table. What about 3 conductors in a table? All right, so now we can handle it. Based on what I read in that title, I know I can handle this particular challenge in this table. So let's go look at the content of the table. Let's go to number 2. So number 2, do I have the right data available in this table? So first of all, over here I see I've got wire size, so it's giving me a range of wire sizes. Great. I scan down through the content of the table and I see it starts at 20 amps and goes up to 2000 amps. So I'm sure that I've got the right range, which is 100 amps, in the table somewhere. And you can't read this in this PowerPoint. I recognize that the writing is too small, but I see that I've got copper conductors here on the left, aluminum on the right. Good, I've got copper, so I know I'm on the left here. And the final thing I'm checking is I can see my wire type, which is THHN, which is a standard wire for pulling through conduit and through plenum. THHN you can buy from Lowe's, you buy it from all sorts of electrical supply houses. It is probably the single most stranded wire available for general use in construction or in machines. So THHN, I can see that. You can't see it, but it's in this column right here. So I know I've got the right column there. All right, so the next step, step 3, is, well, actually step 2 was making sure the right data is available, so let's get there. And step 3 was picking the right column. So step 4 is, how do I find the answer? Well, in this case, I can see 100 amps in the column. So step 4 is find that 100 amps and then slide to the left to get my answer. In this case, it is 100 amps is in the same row as number 3 AWG. So I need a 3 wire size, which is a big wire. It's a big wire. All right, let's go on. That's the answer, number 3. Let's go on to 200 amps. What if I had 200 amps? Well, then I just slide my answer down to 200 amps, and I can use a 3/0, 3/0 wire. Okay? What if we're 200 amps and I chose aluminum wire? Oh, aluminum. Well, I'm on the wrong column because aluminum is on the right side of this table. So I'd slide that over to where THHN is in the aluminum. And now I'm talking at 200 amps. I don't have a 200 amps in aluminum. So how do I solve this? I round up. You can't round down with wire. You don't want to have less ampacity. You want at least equal to or greater. So the next size above 200 amps is 205, and I slide that over. And now I need wire size 250. So if I'm running 200 amp service for a building, and I've chosen aluminum instead of copper, I will need wire size 250. So that's my third example. Now, just to give you a little background, why would I choose aluminum wire over copper wire? Because aluminum wire is cheaper, much cheaper. So if I'm running a 100 amp service somewhere or 200 amp service somewhere, I probably will use aluminum wire. Why would I not want to use aluminum wire? Because it is less durable, and also if you don't do it right, if you don't do the connections right with the right kind of goop on those connections, it will start to corrode much more quickly, and soon you will have a big problem.